This is a topic I touched on during the lecture on transverse and axial mag, but I want to repeat it here and to do an example of a problem dealing with it. Okay, so the idea is that you're given a problem that goes something like this. You are in a movie theater, and let's draw our movie screen here. This is our screen. And you are seeing a picture of a person. And the person is on screen 2 meters tall. Sort of actual size. And you are sitting over here. This is your eyeball. Because to an ophthalmologist, right, you're just an eyeball with arms and legs. You are, for convenience sake, 17 meters from the screen. So the question is, how large is the image of this person on your retina? And initially, it looks like you're not given enough information to solve this problem. But you are. Okay, what I'm going to do is I'm going to draw your eye a little bit larger here. And I'm going to draw your eye. This is your cornea. And this is your globe. Like that. And we're going to draw central rays. Okay? One central ray is from the bottom of the image, in this case, the character in the movie's foot, and striking your retina. Now, through what point does the central ray pass in order to emerge from that point undeviated? And the answer is the nodal point of the eye. Nodal point. And we're going to draw the second ray coming from the protagonist's hairdo, and will also pass through the nodal point and emerge from that point undeviated. So this is just a central ray tracing diagram. We have 2 triangles here that are similar triangles, which after all is the way that we solve these problems, right? This is triangle number 1. And this is triangle number 2. Okay. Obviously, these are the same angles here. And the ratio of the heights is equal to the ratio of the bases. And we know this height is h, which we know is 2 meters. And we know that this base is 17 meters, because that's what you were given. And you're solving for this height, which will make little h. And the piece of data that it initially looks like you don't have is the base of this triangle here. You'll remember in optics there are a few numbers you need to memorize, index of refraction of water is 1.33, air is 1.0, all that sort of stuff. One of the numbers that you need to memorize is this. The distance from the nodal point of the eye to the retina is 17 millimeters. Now, is it really 17 millimeters? Of course not. Someone who is an axial myope, this number is going to be much larger, a hyperope smaller. But for problem solving, from a problem solving standpoint, we're always going to use the distance from the nodal point to the retina of 17 millimeters, unless you're specifically given a different distance. Now it's an easy problem. This base is exactly 1,000th of this base, which is, of course, why I chose 17 meters. So if this is 2 meters high, this is going to be 2 millimeters high. Or h, little h, is 1,000th of big H. And of course, the critical piece of information, the trick, to the extent that there is a trick to these problems, and it's not a very big trick, is to memorize the number, 17 millimeters, which is the distance from the nodal point in the eye to the retina. Thank you.